If all goes as planned,
3, 2, we have main engine start.
In 2007,
And liftoff.
a Delta II rocket will carry Dawn beyond Earth's gravitational grasp.
When that Dawn spacecraft lifts off and we're on our way to finding out about some of the biggest mysteries in the solar system, that's something we can all be part of. It's so cool going to the asteroid belt, this ring of broken up debris between Mars and Jupiter. These are among the last unexplored worlds in the inner solar system.
The asteroid belt is really fascinating because it's kind of like the boneyard of material that's left over from forming all these planets. It's fragments of explosions of planetary embryos, perhaps, during collisions, or material that's come in from other parts of the solar system and been captured into this orbit of the asteroid belt.
We're going out to Ceres and also to Vesta, and these are very different bodies.
Vesta is the brightest asteroid in the solar system and the only one visible to the naked eye.
In one sense, it's sort of like our moon, but in another sense, it's sort of like the Earth. It's got an iron core, just like the Earth does, and it may have had many of the processes acting that the Earth has.
The 3 science instruments on Dawn all work together to tell us about the surfaces of the body. And from that, we try to work back to how the whole thing was put together and what happened to it.
Scientists believe Ceres represents a transition from the rocky terrestrial planets of the inner solar system to the gaseous and icy worlds of the outer solar system.
Ceres likely has a rocky core and a very thick ice mantle. There's even the possibility that there's liquid water under the surface of Ceres.
We estimated from our measurements with Hubble Space Telescope that it's got almost 100 kilometers of water on top of a rocky core.
To accomplish Dawn's journey into the heart of the asteroid belt, a spaceship, one whose engine will work without fail for years at a time, is required. Dawn's remarkable ion engines employ electrical currents, magnetic fields, and xenon. The high-tech innards of an ion engine change the xenon into a positively charged plasma and accelerate it out the engine at speeds over 78,000 miles per hour.
The ion engine pushes on the spacecraft about as hard as this single piece of paper pushes on my hand. But this very gentle thrust eventually builds up and allows the spacecraft to achieve very, very high speed. With the ion propulsion system, Dawn will be the first spacecraft ever to orbit 2 target bodies after leaving Earth.
A mission into our distant past, a mission for the future, a mission into the heart of the asteroid belt, a mission called Dawn.